today you're going to be an engineering student too. Now we want to figure out how we can cool down our houses without using electricity, only using science and engineering.
Engineering is cool.
Yeah, she's right. Engineering's awesome. So first we're going to learn about convection. Now convection is the transfer of heat through a fluid. Fluid is like air, water, and so we can use this idea of convection to help us cool down our houses. Now, convection, we want to focus on the movement of the air molecules, like a breeze. That's breeze is when the air molecules move by you. So we want to see how the air molecules move when there's a change in temperature, like when something is warming up or when something is cooling down. So a convection current is when hot air rises and cool air sinks. So let's find out why. Here's Jess to help us out.
Molecules like to move around, especially air molecules. And as things get hotter, they move around a lot more. So on this side, I have hot molecules. So what do hot molecules like to do? Hot molecules like to move around. And in the process of moving around, they like to take up a lot of space. Now, on my right, I have cold molecules. We gotta squeeze together. What do things like to do when they're cold? They like to huddle together. So cold molecules take up much less space than hot molecules. So cold molecules are going to be dense because they take up less volume than hot molecules.
Okay, cool. So hot molecules are less dense, meaning they take up more space. But why does that mean that they move up? Let's go to Sophie and see if we can figure this out.
So if hot air is less dense, will the hot air move up or down? Well, we can figure it out using these. Here I have this paper clip and foam. And the paper clip is much more dense than the foam. So I put a little piece of foam into the water. And then I'm going to put a paper clip and see what happens between when one high density object is in water and one low density object is in water. Paper clip sinks right to the bottom. So more dense objects sink to the bottom. So air, hot air, which is less dense than cold air, rises to the top, where cold air sinks to the bottom.
This is Anthony from PS5, and Anthony and his mother made this really awesome house that's designed for where? Where did you design it for?
For where? Oh, for Hawaii.
For Hawaii. So this is going to be in Hawaii where it's so hot, and we want to cool this house a lot. So one thing that Anthony did was put in a chimney at the top. Now he said that with convection, hot air rises to the top. So if we can find an escape for that hot air to get out, then that would really cool the inside of our house. So Anthony put this chimney so that the hot air can come right out. This is a great design to cool the inside of the house. And it's a tall house. By making it a tall house, the hot air stays at the top, away from where the people are going to live. So good job, Anthony.
So you can build a model house just like Anthony's using materials that you find around your house, like cardboard or tape, construction paper. You can even think about how to reuse some other materials that you would usually throw away, like a water bottle or a plastic bag. All of those elements can be incorporated into your house design. And you can use a chimney just like Anthony. But I've got a special challenge for you. Where would you put a second opening to allow more cool air into your house, cooling your house even more?
Now there are a lot of options for where the second hole can go. It can go at the bottom, it can go at the top, it can go on the same side as your chimney, or it can go on the opposite side. It's up to you to figure out what is the best position to let cool air in and allow for the greatest movement of air molecules throughout your house.
Now, when you test your model, you can use incense, but make sure to ask an adult first. Get an adult to help you light an incense stick and hold it near your house. That way you can watch the smoke trail and find out where the air is going and see if you really have a good convection current. You can also use a thermometer to help test the different temperatures around your house to see if it really is cool.